Today we're doing more transformations. No, settle down. You're okay. Why are some of you excited about getting to this? Because you already know how to do it, don't you? Okay? How many times have we done transformations already this year? 4 or 5, something like that, right? So you also have a foldable, right, that you could get out and use if you needed it. So I could even just not teach you anything today and you could still be successful in this lesson, right? I'm going to choose to teach a little bit just to make sure we understand, okay? Because, first of all, it's my job. Second of all, what we always have to try to figure out is what? When we're dealing with transformations, what are the 2 words that we always associate with transformations that we have to figure out? Inside and outside, right? So what we have to figure out is, in this particular kind of function, what does inside mean and what does outside mean? Okay? Well, if this is the parent function right here, 1/2 to the x power, what's going to be inside? Inside the exponent. Yeah. It's called an exponential function, so that should give you a hint right there, right? We want something, everything that's inside the exponent is going to be our inside stuff. That's going to be our horizontal changes, okay? And anything that's not inside the exponent is going to be our vertical changes, right? Okay? So if we're talking about this function right here, g of x, compared to f of x, how does it move? Well, start from left to right. What does this cause? A reflection over the x-axis. That's right. Okay? It's outside, so it causes a vertical change. That's over the x-axis, right? What does the 5 cause? It's a vertical stretch by a factor of 5. That's exactly right. Okay? Again, vertical because it's outside, right? We're going to come back to this in a second. What does this cause? So this is inside, right? So it's going to be a horizontal. That's perfect. Yeah, horizontal shift right 4. Okay? And then what about this? It's outside, so it's a vertical shift up 6. Got it? There's not really many ways I can make this very much harder. This is like one of the hardest that you'll see. I figure if we could do the hardest, we could do the easier ones, right? So I said a minute ago we're going to come back to something. Do you remember what that was? The 1/2, right? What kind of change does the 1/2 cause? None, right? If we start with 1/2 to the x power, that's like the parent. Okay? Now, exponential functions are kind of wonky. Okay? Because of the fact that if we're talking about linear parent functions, that's y equals x, right? No questions. If we're talking about quadratic parent functions, that's y equals x squared, right? No questions. What else do you know? X cubed. Yeah? Y equals 1 over x, rational, right? Those are all the exact parent functions, right? No doubt, no questions. Except exponential is different. This is a parent function, right? This is the parent function for cubic. There's only one, right? But f of x equals 2 to the x. Isn't that also a parent function? Nothing's being added, subtracted, or multiplied, or divided from this function, right? So that is a parent function for exponential. It could be 3 to the x. It could be 7 to the x. It could be 12 to the x. It could be 1/3 to the x. It could be 1/5 to the x. Those are all parent functions for their family. Does that make sense? So whatever the base is of our exponent, that's just the base. That's just what it is. No matter what this number is, it doesn't cause a change from the parent. It's just a different base. This could be 1/2, like I said. This could be 2. It could be all these things and so much more, right? How many different possibilities do we have for the base? Yeah, an infinite amount, right? Literally, we have an infinite number of parent functions for exponential functions. So don't let this 1/2 confuse you and think that that has to be a vertical shrink or horizontal shrink or compression or something like that. That's what was in the parent. It has to be here because that's the parent. Okay, that's the base, the main function, the original function. Does that make sense? That's been the quote-unquote hardest part of this lesson today, is people try to do something weird with that, and you just don't. You just kind of ignore it. That's just part of the parent. Yeah? That's part of the family. Does that make sense? Are there any questions? Do I need to do a whole bunch more examples? You got it, right? If it's outside, it causes a vertical change. Excuse me. If it's inside, it causes a